Hello, this is Mr. Tipton, and today we are looking at the coordinate plane. That's this object, this figure over here on the right side of the screen. The coordinate plane is made up of two number lines that span both positive and negative numbers. Here horizontally we have our x-axis. You can see the little x there. And vertically we have the y-axis. Okay. The way that we plot points that usually represent data are given to us by ordered pairs, is what they're called. Ordered pairs are in the form x and then y. That was supposed to be a comma. Let's try that again. X, y. Okay, so the first number, the x value, tells us which way to go along the x-axis, which goes left and right. And the y number tells us which way to go vertically, up and down. Okay, so we always start, when we're plotting points, at a point called the origin. Okay, origin is at 0, 0. It's right in the middle where the x-axis and the y-axis intersect. Alright, so again, that's called the origin, or that's an O, O-R-I-G-I-N, right in the middle. But plotting other points, let's say we want to plot point A at, let's say 3, 2. Okay, so again, the 3 tells us how to move along the x-axis, and then the 2 tells us how to move on the y-axis. So 3, 2 would be right here. We went right 3, and then we went up 2, and that is point A. Alright, now point A is in quadrant 1. As you can see, the coordinate plane is divided into 4 sections, or 4 quadrants. Okay, quadrant 1, given in a Roman numeral, is up here in the top right, and both of our x and our y values were positive. Quadrant 1, everything's positive. Let's see, point B. Point B I'm going to put in quadrant 2. Okay, quadrant 2 is up here in the top left, and again we're using Roman numerals. And if I did -4, 1, I would have a point in quadrant 2. I'd go left 4 to the -4, and then up 1 to the +1. Okay, that's point B. We've got quadrant 3. I'm going to abbreviate. Quadrant 3 down here in the bottom left. Both of my numbers will be negative. To be in quadrant 3, if I do -4, -4, then I have a point right here, point C. And then we've got quadrant 4, Roman numeral 4 is IV, down here in the bottom right. And let's do 5. The x is positive, the y is negative, to get me into quadrant 2. I'm sorry, quadrant 4. Okay, so that's just a quick overview of the coordinate plane, ordered pairs, quadrants, x-axis, y-axis, origin, basic stuff for plotting points. Let's take a look at some other stuff. We may, at some point, be asked to find the distance between 2 points on a coordinate plane. There's 2 different ways we can do that. First way is with the distance formula, and it's pretty ugly. It's the square root of x minus x squared plus y minus y squared added together. And then we also have the Pythagorean theorem. Maybe you've heard of that. A squared plus b squared equals c squared. The a and the b sides of the right triangle. Got a right triangle over here. The A and the B are the legs that make the right angle, and C is the hypotenuse of the triangle. So what this says, if you take the A side and you square it, and the B side and you square it, it will equal the long side squared. Anyway, I'll show you how that works here with a couple examples. I think I have distance formula up first. Alright, it says find the distance between the 2 points. We've got -9, 2, and -3, 10. Okay, using the distance formula, well, first of all, I can't just draw a straight line. Well, I mean, I can draw a straight line, that's what we're looking for, but I can't measure it because they're not, how do I say? I mean, you see my straight line, it doesn't exactly go nice and pretty between the different squares, the grid on the coordinate plane. Now, if I had points like here and here, I can tell that distance pretty easily. It's just 1, 2, 3, 4. Those are 4 units apart. Same way if they were lined up horizontally. Okay, from 2 to 10, those are 8 units apart. That's easy enough. But these 2 points are not in a nice pretty vertical or horizontal line from each other, so we're going to have to use the distance formula. Alright, now these x1 and x2s, you can see how they're supposed to be lower. An exponent like the squared, that's raised, but these 1 and 2s, these are lowered. That's called a subscript. Okay, all that's doing is identifying the x and the y from the 2 different points that we have on our coordinate plane. Alright, now I'm just going to call this one point 1 and point 2. It does not matter. We could have made -3, 10, 1, and the other one 2. We would still come up with the same answer because no matter which way we go, they are the same distance apart. Alright, anyway, I'm going to plug in these numbers. So x1, okay, point 1, my x value is -9, minus my x value of point 2 is -3. Okay, all that squared, plus the y value of my first point is 2, minus the y value of my second point is 10 squared. Alright, now I'm going to rewrite this with one sign combined, -9 plus 3. Alright, that's going to clean some things up for me. -9 plus 3 is -6, and that's going to get squared, plus 2 minus 10 is -8 squared. Okay, square root of -6, I'm sorry, -6 squared is 36, and -8 squared is 64. And I'm going to go here to the right because I'm running out of room. 36 and 64 is 100, and the square root of 100 is 10. Okay, technically positive and -10, but there's no such thing as negative distance, so the distance between these 2 points is 10 units, I suppose, on the graph. So that's the distance formula. Alright, I'm going to show you how to use the Pythagorean theorem to find the distance between the exact same 2 points. Alright, we know that we are looking for this diagonal line between them. Okay, we can make a right triangle out of this. And that's when you use the Pythagorean theorem, is when you have right triangles. Okay, remembering from our notes, A and B make up the right angle, and C is the hypotenuse. It's the side that is across or opposite of the right angle. Okay, now how much is A? Well, this we can count. 1, 2, it's from 10 down to 2, so the length of side A is 8 squared. The length of side B is 6 squared, and we're trying to find the length of side C. Okay, 8 squared is 64, 6 squared is 36, is equal to C squared, and these are familiar numbers. Okay, now we're not interested in C squared, we need C. So to undo c squared, we take the square root of both sides, and we end up with c is equal to 10, just like we did on the other screen. Alright, so we will have to do some distance finding between points on the coordinate plane, and there's a couple of ways that you can do it when the points are not lined up nice and pretty horizontally or vertically. Alright, if you have questions, keep track of them and we'll talk about them in class. See you soon.